in this example, we're going to go ahead and find the intervals where the function is concave up and concave down, as well as the inflection points. And this time it's for a logarithmic function. So the thing to remember always with a logarithmic function is that the area inside the logarithm always has to be greater than 0. So we have definite limits on what our domain is here. So take a look at this. So in order for us to make sure that any critical values or partition numbers we find actually fit in with the function or are part of the domain, we need to know what the domain is first. So 3x plus 6 has to be greater than 0. When we solve that out, so subtract 6 from both sides, we get that 3x has to be greater than -6 divided by 3. That means that x has to be greater than -2. So my domain for my function goes from -2 to infinity, like that. Okay, so let's go ahead and start taking derivatives. All right, so taking the derivative of my function. First thing to notice here, okay, is that this problem right here is a chain rule problem. It's a function within a function, right? My outer function is natural log. My inner function is 3x plus 6. So I take the derivative of the outside. So remember, when I take the derivative of natural log, that's 1 over whatever's inside. So it's 1 over 3x plus 6. And then I multiply it by the derivative of the inside. Well, the derivative of the inside is just 3. Okay. So this becomes 3 over, and what I'm going to do now is I'm going to try to simplify this as much as possible. And you'll see why this is important in a second. So I'm going to factor out the 3 from the bottom, and this is 3 times the quantity x plus 2. Now notice, now I can factor a 3 out of the top and a 3 out of the bottom. So my derivative, okay, my first derivative is 1 over x plus 2, or I can write this as x plus 2 to the -1 power. And this is going to be helpful because now I need to take my second derivative, okay, and instead of doing a quotient rule and doing something like that, here I can go ahead, and this is just going to be another chain rule in kind of an easier way of doing it. So I take the derivative of the outside, which is raised to the -1 power, so I bring my exponent down, -1. I write down what's inside, and then I decrease my exponent by 1, just like that. Then I multiply that by the derivative of the inside. Well, the derivative of x plus 2 is just 1. Okay, so this turns out to be -1 times x plus 2 to the -2 power. Okay, which means that, so my second derivative is equal to -1 over x plus 2 squared. There we go. All right. Now again, I want to find my critical values or my partition numbers. So this is going to be where the second derivative is equal to 0, or the second derivative is undefined. All right, so remember the second derivative, it's going to be equal to 0 for our second derivative here. That means that the numerator has to be equal to 0. And well, yep, -1 is never going to equal 0. So we don't have any situations where our second derivative is equal to 0. Okay. Now where our second derivative is undefined, that's going to be where my denominator, x plus 2 squared, is equal to 0. All right, well, that means that x plus 2 is equal to 0, which means that x is equal to -2. Now then, look at this. This is why we calculated our domain to up there at the beginning, okay? My domain starts at -2, but -2 is not part of my domain, okay? So therefore, this x equal to -2 is not in the domain, right? So it's not a critical value, okay? So how am I going to do that with my sign chart here? Well, okay, so I have -2 here. I'm going to put it here at the end. I'm going to put an open circle because it's not a critical value. Oops. Come on. Let me try doing the circle again here. There's my circle, okay? And this is at -2, okay? Remember, like I said, -2 is not part of the domain. Everything is to the right of -2. So I'm going to pick a number that's to the right of -2. I think 0 will be a good choice. All right. So I'm going to take the second derivative and I'm going to put 0 into it. So the second derivative is -1 over 0 plus 2 squared, okay, which is -1 over 4th, which is -1/4, which is less than 0. So that tells me that the entire interval, the entire domain of my function is concave down. Okay? So based on that, I know that concave up is not applicable. I have no intervals where I'm concave up. Concave down, I know that's going to be on the interval -2 to infinity, which happens to be the entire domain of my function. And as far as inflection points, well, since nowhere does the concavity ever change, there are no inflection points. And there's our information.